Now, in this problem here, the population of a town is currently 30,000 people, and the population is going to double every 14 years. Let's see if I could help you understand your version of this question by guiding you through parts A through D. So for part A, we're asked to figure out K, the growth rate. Well, for that, we're going to simply use again the formula that K equals to the natural log of A of t, or A of 0, divided by the time it takes to get from the initial amount to that new amount, okay? Let me put this backwards, actually. I want to put this over here. Let me move this over here and put this over here. So we determine the value of K by doing this. So we're going to look at how much we're going to start, how much we're going to finish, and divide that by the time it takes us to do that using natural log. Now, since we're starting with 30,000 people, it's going to double in 14 years. So we know in 14 years, this amount is going to be 60,000. And because it's doubling, that means that this ratio is simply going to be the number 2. So I have two options. I can write this as the natural log of 60,000 divided by 30,000, which simply simplifies to 2. And then divide that by the years it takes to double it, which is 14 years. So let's plug this into decimals and let's see what we end up with. So here I have typed it into decimals, and I get that the natural log of 2 divided by 14 is equal to this decimal value here. Now, just to back up and so you understand this a little better, why is this number going to be 2? Regardless, hadn't I even started with 30 or whatever, it's always going to be 2 because it's going to double. Since I start off with 30 and I ended up with 60, 60 divided by 30 is going to, look at this decimal value, it's the same thing as when I plug in the number 2. The key thing that I want you to understand here is that because we're doubling, it doesn't matter that we know, or maybe we won't know what this initial value is. That just as long as we know that we're doubling it, this number inside the parentheses is always going to become a ratio of 2. So it won't make much of a difference if it was 30 to 60, or as you'll see here, 40 to 80. Notice that these two decimal values are the same. Now, to round our answer, we want to round our answer to 3 decimal places. So there's 2 options to do that. I can type in the decimal value that we got, 0, making sure that I just write more than 4 decimal places, more than 3, 4, 9, 5, 1, that's good enough. Put in a comma, and then 3. So if I type in the command round, type in the decimal value that I want to round, and then put a comma, and then the number of places I want to estimate it to, which in this case is 3 decimal places, I get this value of 0.05. Now you're wondering, well, what's happening to the third decimal value? Well, it's because that number is 0. So you see the 49 estimates up to 50. So it's 0.050 if you want to write all 3 decimal places. Another way of doing that, where we can do it in one entry line, is by simply typing that command up here, typing in my expression, and then after that typing in my comma and then the number 3, okay? So that's another way of doing it. Now if you don't put the comma after you type in the command and don't put the comma, by default it estimates to 0 place values. So you get 0 because the first number in this decimal is 0. So no decimal values are going to be estimated. Okay, so here we have our value of K, 0.05. So for part B, we're now going to use that number to write the exponential growth model using this value of K. So here we're talking about the population of a town, so we'll call it P of t. This will start off with 30,000 people, e to the power of 0.05 times t. So this is the answer to part B. Part C asks us to estimate the population after 27 years. So using the equation or the model that we have in Part B, we're going to evaluate the population in 27 years, which simply requires us to substitute in 27 for the letter T. So starting with the 30,000 people, E to the 0.05, and replacing T with 27. Now let's just plug it into decimals and see what number we get. So here, having it typed into decimals, I get this value here. I want to round this to the nearest whole number, so no decimal places. So I'm going to put the command round and type in my answer 572.27, and well, it's going to just be 11,572. So to 0 places that. And remember, I could also do it by in the one entry line. Just put this same command up here, comma, and then 0, or no, just put rounded and estimates the nearest whole number. But here's our answer. And now finally for part D, let's determine the time when the population is going to reach 190,795 people. So that means we're going to use again the model from part B. So this 30,000 E, raise it to the 0.05 T, because we don't know what T is this time, and find the value of T by setting this model equal to this desired population. So our steps are going to be the same as before. From our notes, we're going to start by dividing this amount by the 30,000. That's going to leave us to E to 0.05 T. We're going to get rid of the letter E, the base E, by taking the natural log. So I'm going to take the natural log of this side and move this over, and the natural log to this side. So that'll eliminate this, leaving us with 0.05 T equals to the natural log of 197.95 divided by 30,000. And the only thing left to do is to get rid of the 0.05 in front of the T. Since we're multiplying, we'll divide by that. So all of this gets divided by 0.05. So here is our answer. T is equal to the natural log of 190,795 divided by 30,000. And all of that divided by 0.05. So let's plug this into decimals and see what number we get. But before we do that, again, look, I want to show you this shortcut. So all we're doing is getting this, dividing it by that, as you see right here, taking the natural log of this, and divide it by that. So anytime we have an equation, like this, the format of our answer to finding T is always going to be the same thing. It's going to be some natural log. It's going to be the natural log of the desired amount to the initial amount divided by our K, by this number right there. So you can use that shortcut instead of doing these 3 steps, doing step 1, step 2, and then step 3. You can go straight to the answer because it's going to be the same format every single time. All right, so let's determine the answer. I'm here on decimals. I'm going to type in round. I'm going to type in natural log, and inside that parentheses of the natural log, I want to divide again the 190,795 divided by the 300,000. I'm sorry, the 30,000. There we go, 30,000. Closing the parentheses on that, and then that being divided again by our K value which was 0.05. So rounding that to those decimal places, that's going to be a total of 37 years. So it's going to take 37 years sorry about that, 37 years for the population to go from 30,000 to 190,000 and change. Now, I hope this video was helpful, and I appreciate you watching.